So we are doing, so I'm going to talk about building an internal developer platform. So in the earlier session, Fikri and Alinga gave you an intro on what the cloud native landscape, the tools that are provided in the cloud native landscape. Now I'm going to talk about how to build a platform using those tools. So a little bit of history on me. My name is Nilesh, as you all know. Here. I am an architect at WSO2, and I've been working with Kubernetes, I think, from 2015 onwards. And we've been developing platforms on top of Kubernetes for a long time. And we've been using many of the tools that were showcased in the cloud native landscape and then cloud vendor specific one, and we were doing a lot of DevOps stuff because we were building a tool that was automating DevOps functionality. So you need to know both development and DevOps stuff. So let's look at how the industry has come forward. In the early days, we had monolithic business apps, then we had enterprise apps, and fast forward a few times, and then in 2010 we had APIs. And APIs was a big thing back in 2010s. And today it's all about serverless and microservices, which Fikri and Kalinda spoke about. We have monolithic architecture and we have the microservices architecture. And if you saw a recent blog post from Prime, they have actually reverted back to monolith to save back 90% of their cloud cost. So, pros and cons. So, depends on like, if you break your microservice into a very lower level, at a nano level, yes, you will have encounter a lot of cloud, because you think about the availability, you would have a minimum of 3 replicas and all of it is going to consume a lot of infrastructure, but you have to be mindful of how much you break your domain to the microservices. Then I think it should be okay. Even at WSO2, the project that I'm working on, Choreo, I think it has about more than 100 microservices now. It's very hard for the architecture team even to get a scale of like to manage like which is talking to which, how things are working and all of it, and the scaling. There's a lot of problems. Like when microservices grow, your architecture grows, and sometimes it's hard. So I'll just quickly talk about cloud native design principles. Kalin can quickly touch this a bit with 12-factor apps. So one thing that 12-factor, there's a book called Beyond 12-factor. So in the modern cloud native world, there are 3, it's called 12 plus 3. There are 3 core factors, the addition to 12-factor, which touches the observability and all of the other things. So containerization is there, that's the first thing. Although not really containerization, but rather bundling your application with the libraries that are needed to run that application. Right? Containerization is one way. There are other ways that you can do with build packs, and few other ways you can bundle the apps together. Second one is microservices architecture, which we already spoke about. Then the scalability and elasticity. Of course, your application, if you are developing for cloud native, you need to think about the stateless. Like your application should always be stateless. You shouldn't be writing stuff into the folders of your root directory or whatever. You should be writing to a blob storage that's external. Can't keep sessions anymore in the memory. You have to export the sessions to a database or a Redis cache or something like that. So that's how you make your application stateless. So in the cloud native world, we treat these applications as cattle. Cattle as in there's this thing called pets versus cattle. Pets, we nurture them, we love them, whereas I'm no animal abuser, but cattle is normally you kill them, right? So cloud native applications should be able to kill, and then they should get respawned up, and your application shouldn't have an effect. The functionality of the application shouldn't have a problem. Right? Then the next one is automation and DevOps. So there's a saying, everything, your job should be automated, right? So that should be the goal of every enterprise at the end of the day, automating everything. Then cloud native data management. So there's many ways you can manage your data and streaming the data. There are tools for those. Then even saving the data, the databases. It's okay. MySQL, you can do cloud native. MySQL is an open source one, and each cloud provider has a managed service for MySQL, and that's fine. But if you go with something like, I don't know whether each cloud provider has a MySQL. I don't know whether I can disavow Microsoft. So, but if you go with a cloud vendor specific one, then it's not really cloud native. It's all about using services that would enable you to jump between clouds and that work with on-premises as well. And finally, observability and monitoring. How you would observe and manage how you can observe your application running. So I believe a lot of you come from universities. So this is how normally enterprise architecture looks in a cloud native computing era. As you can see, there's end consumers, and then there's something called experience APIs or BFF. That's called backend for frontends. This is basically GraphQL layers, more REST API, stuff like that. And then only you have domain and business logic servers and integrations. So like, I'll take WSO2 for example. WSO2 as an enterprise, they have a separate system for payroll. They have a separate system for HR. They have a separate system for attendance and all of these things. And then those will be the domain services and domain data. And these will be separate apps. Some are not developed by WSO2 but by other vendors. And they have APIs. That's where integrations come. And these integrations would be here or it could be here. So this is where the GraphQL layers and everything would work together and provide us applications to see, to mark our attendance or like apply leave, put request of salary slips, stuff like that. That's how enterprises work. It's not just writing a simple monolithic microservices architecture, but this is a vast area. A lot of integrations, a lot of different systems out there, and then we write integrations for them to work together, and then you get right. So what is an internal developer platform? So this is a ChatGPT definition. So yeah. So it took from internaldeveloperplatform.io. So what an internal developer platform basically is, in an enterprise, in any enterprise, there's an IT division or IT sector, and they would be developing applications for the enterprise. And when they do that, they need to now do CI/CD, from code to production. There should be a process for this application to go. Internal developer is what facilitates that. It's something that enables developers to go from code to production instantly. Normally this can be termed in other ways platform engineering in these enterprises. They hire big platform engineering teams who would set up these CI/CDs and do all of these things so that developers can ship code to production with ease. Even WSO2, we have a huge platform engineering team, and we have a lot of configurations, and to introduce a system to production, there's a process that we have to follow with security, governance, and all of that. So what an internal developer platform would do is, it would enable the developer to go through that process quite easily without having to do much. Just a couple of clicks, your service is deployed, dev done, production done, right? That's what internal developer platform is in a nutshell. Any questions? So yeah, and every company needs an internal developer platform. It's just basically platform engineering reimagined, basically. So we will talk about key components of an internal development platform. So now what I'm going to get you guys through is like this section. Yeah.
So are we not limiting ourselves like to a set of technologies that is maybe we used to say like 2-3 years ago? When the was
Yeah, certainly, because because now you are defining a platform for you to use from code to production, and of course this will also get renewed. And if you look at platform engineering, what they will do is they would keep noise. Okay. Okay. So so platform engineering, what you do is you define a set of processes, and normally that process is the one that the enterprises would follow, and after a while something new happens, and then you change your processes, and then go on. Same thing with internal developer platforms. Although there's another problem with the cloud native tech that we just spoke about, especially with enterprise people want SLAs. That's like the thing that they want the most. They don't care about money. It's the assurance that they need, so that like you can't just go to an enterprise and say I'll use Argo CD. They would probably ask for SLA, and they would say I want the enterprise license for it, all of that. That is because the CTOs, CIOs, they need to keep their head clean, and if something happens, they want the proper support from the team that developed it, right? That's how these enterprises work. So how many, there are odd enterprises who would be the risky person who would work with this or use an open source software, stuff like that. But many enterprises, even WSO2, being an open source vendor, how we earn money is by enterprise support. They use the open source software, but they have to pay us for support. That's how it works. That's the industry. So similarly, in internal developer platform also, you build with these tools, and then you would buy enterprise support according to your needs, and then you would have the option to change them, because you are building it for your organization, right? So that's how it is. Or you can buy an internal developer platform in which the risk is on the person who sells it to you, and they would be changing things according to your needs. And the other thing is, you have to look at requirements rather than the technology. Don't go after, like in the developer platform per se, right? As developers, go after technology. But if you are a CTO, CIO who's deciding something for your company, you have to think about the requirement, not the technology. Technology is irrelevant. If your requirement is met, that is it. Okay? Right. So the key components of an internal developer platform. Now, I would be giving some options. I don't have fancy slides like Kalinga had, so I did it last minute. So so in each section I would provide a bunch of tools in which you can do to build your internal developer platform. And most of these are enterprise cases, but if you have your own project, you can use these things and get started with a small CI/CD pipeline, right? It's basically platform engineering and go to the highest level. So containerization is the starting point, and I think Kalinga covered what containers are and how we do things. So the tools you can containerize, I think Docker is the main one, but I don't know about your company, but WSO2 has asked us to uninstall Docker because of a licensing issue. If your company is using Docker, they can sue you and ask for money. Something like that for enterprise. So there's another thing called Rancher Desktop, which uses Moby behind the scenes. You can still use the Docker commands, but the engine is Moby. So it does the same thing. So, and then there's other things like build packs, which is in the CNCF landscape, which would allow you to build your applications. Now, build packs, for example, is you don't even need to write a Docker file. just give the code to it. It would automatically scan your code. It has a bunch of templates. If it's Laravel, it would build a Laravel, automatically build a Laravel image. If it's Node.js Express, it automatically build that. React, Angular, it would understand and build it automatically. So that's called build packs. Check it out. It's in cloud native landscape. So there are other ways you can build. So that's containerization. The next one is orchestration. Now orchestration, when it comes to orchestration, we think about Kubernetes, right? So basically the requirement of an orchestration is managing your running workloads, how to manage your running containers, how to manage your application, right? To do that, we have now infrastructure in our cloud or even in our data center, but we need to do the resource allocation, right? Which container runs where, how to schedule it, how to scale it, how to do the network discovery, track state of it, and if it's, if there's problems with it, kill it and restart it somewhere else, stuff like that. This is what an orchestrator does. So Kubernetes is the open source solution for this. And there's Docker Swarm, but nobody uses Docker Swarm anymore. It's dead, sort of a thing. Rest in peace. But Kubernetes is the main one. But I think I saw there's only one guy who has done Kubernetes here, right? Oh, one guy, okay. That was right. So anyone else, if you have tried to deploy on Kubernetes, to do a simple microservice that has a bunch of environment variables and stuff like that, you have to write a deployment YAML, you have to write a service YAML, you have to write a config map, you have to do the mounting, and then if you want to do horizontal scaling, you have to write a horizontal pod autoscaler. There's a bunch of YAMLs that you had to write, and there's a bunch of concepts that you need to. Now, I've been training Kubernetes for a while now, for a lot of companies. And what I see is people get really, really confused with all of these YAMLs, how to mount them. There's volumes called MTDIR, multi-containers, pods, and all of it. Right? So it's confusing for a lot of people. But it's a good skill to have. Learn Kubernetes, it's good for your jobs and career. But for an enterprise who has either bunch of system engineers or developers, they don't know much about Kubernetes. They know how to code, but not much about the deployment side. For stuff like that, clouds provide you services like AWS ECS. Azure provides container instances. Google has App Engine, Cloud Functions, and many more, right? So all of these are orchestration platforms which would take your container up, spin your container up, and manage traffic and do all of that for you. Ready? So that's orchestration. Any questions?
Yeah. Actually, it's from the previous slide, containerization. So what is the advantage of using a build pack over a containerized like Docker or Mobile? So what is the advantage and disadvantage?
Right. So Docker, basically you define the build configuration, right? You as a developer, if you're writing a Python Flask app, you have to write the Docker from, and you have to decide which image to base image to get from, and you have to figure it out and you have to write it. Right? Usually it's for normal applications, it's just one Docker file, you would copy it from somewhere and it would work. Build packs, the idea is you don't need to know about Docker. It would generate the Docker file for you behind the scenes, and it would build the layers, trim it down, and then give you the output, which is the image. You don't need to write a Docker file for build packs. It's pretty good because see what the advantage of build packs versus Docker file for an enterprise is. Let's say enterprise would have certain rules, like you can only run Alpine images. You can't run Ubuntu or whatever, right? If the developer is defining the Docker file, developer would be writing. Developer has the ability to write where the base image is going to be and all of that. But with build packs, you can actually create a template engine and say that okay, these are the frameworks, these are the base images, and so you can define a lot of things in build packs, and then you can provide it to your company, developers in your company, and they will be using build packs, and it would get built only using those things. So it's a sort of a governance thing also, right? So those are the pros and cons. Yeah. But there you can do governance with Dockerfile also with a simple plugin to GitHub. But yeah. Any other questions? The next one is continuous integration. So continuous integration and continuous deployment go hand in hand, but I've broken it into 2 slides. I think these are pretty standard things. When you do a deployment, first one is unit testing, which I think if most of you are developers, we hate writing unit tests, right? I personally hate it, but you have to write it. So the next one is quality testing. So normally, SonarQube or something, you connect it up, it would have by default quality gates for you, and it would tell you if you have mistakenly committed a password or something, or if there should be a while loop which can be converted to a for loop, or it would give you good advice if your PR reviewers are not giving good advice. So yeah, so that's SonarQube. And then we have vulnerability testing. So to this open source tools which is available in CNCF landscape are Trivi. I don't know if the Snipe is there, but Snipe comes with Docker. But Trivi is the most famous one in the open source world with Aquasec. So vulnerability testing, what it does is it scans your code, especially built images, and then it tells you like what are the vulnerabilities available. Maybe it can be in the packages that you have imported. Maybe it's in the base image of the Docker file. So these are there. So usually if you use Alpine images, the vulnerabilities are pretty low. Base image as Alpine, whatever the language you use. But if you use something like Jessie or some Ubuntu something, that's a high chance you are going to get at least 5 critical vulnerabilities. Then you will have to manually fix them. And there are scenarios where you have to use those base images because Alpine lacks certain libraries. Those are special edge cases. The next one is integration testing or API testing. You've done your unit test, it's passing, but in a microservices world, how effective is unit test really? Because in microservices you have A, B, C, A talks to B, B talks to C. So you can mock B and you can write a unit test for A, but does it really make sense? Because if somebody changes on B, the unit test passes, but in actual production it will fail. So that's why integration test comes. You spin all 3 up, and then you do the full request and see whether everything is working. Usually we do this with Postman, and there are other API testing tools as well, which you can Google. I don't think API level these stuff are there on Cloud Native. Do they have?
Yeah.
Okay. I haven't seen. So the next one is load testing. Selenium is the most popular tool out there to do load testing. So you can basically do like for WSO2, let's say that we usually have, when we release software, we have a spec that we have to follow, and we have to say 1000 requests per second is a must. So we have to prove that it works. So taking the API spec out, we have to fire these things, fire the script and show the load and say that the specified CPU and memory for that particular application matches the load, right? So you have to prove that. So that's load testing. And finally, artifact registry. So I think you build an application, you have to push it somewhere, right? So that's content registries. If you are building a library, it's npm, JFrog, wherever. So the tools, as we mentioned, so I spoke about individual tools, but as a platform to utilize these tools for CI/CD. Usually GitHub Actions is pretty popular these days, although it has numerous downtimes. GitLab pipelines is also pretty good if you are running a GitLab, if your company is running GitLab. Other than that, Farlinger spoke about Tekton, which is similar to GitHub Actions, but it's native to Kubernetes and which is pretty good. It has this concept called CRDs, and you can define it as a Kubernetes YAML and apply. It's pretty good compared to Jenkins and all. It's a very good experience. And there are other vendor specific pipelines like Argo Workflow is there, and there are a lot of things. Azure DevOps is there. So there's a lot. Okay, any questions? Okay, I'll go to the next one. The next one is continuous deployment. I just randomly found that image and put it on the drive. I'll explain what that image is too. For the continuous deployment, one thing is promotions. So you have deployed to development or QA, and then you are ready to do a production build, production release. That's normally, many companies, they do this manually because they want to properly see this through. Some even have automated it, like Netflix and everybody. I don't think they do manual promotions to production. The system is pretty good, but like Dialog, everybody else, I think they do manual promotions. And then release strategies, I'll explain release strategies in the next slide. So blue, green, Canary, rolling, so these are the release strategies you would use when you deploy to promotions. Although in the next slides they look nice, but to implement it, there are a few things that you have to do. Like for example, in Kubernetes, rolling update comes out of the box. I had to do a Canary release or a blue green. That's not quite easy, right? It's hard, right? So yeah. And then the other thing is release metrics. So this is how you measure how your company or how your applications, the engineering of your company, right? So like how many deployments you do. That's what those images are. How many deployments that you do for your project, the deployment rate per hour, per month, and then lead time to change. What that means is how much time it takes to take a commit from the commit time to production. And the next one is change failure rate. How many production deployments are failing? And then finally, mean time to recovery, which means if there's an incident in production, an issue, how much time did it take for your team to recover from it? It's not about a pod crashing. It's about a customer or somebody using your system, recording a bug as an incident in your system, and then how long did it take for you to recover, right? So this is called DORA metrics, and this is a standard for measuring the engineering success of a team that's using microservices. Okay, and the tools that give us, CD or Argo CD. There's Harness, which provides DORA metrics and all of it as well. There's Flux, and then alongside with Flux, there's something called Flagger, which gives us the ability to do blue, green, and Canary quite easily. And there are many others as well, which allows you to do CD. Any questions? Rashanad?
These images are these like the standard values?
Yeah, so these are, I got it from Google. I assume these are the real values, but as you can see on the bottom, time to restore, it has been 1 week. Basically, there has been an incident in production, and it has taken about 1 week on average for them to recover from it or fix that issue. An incident doesn't mean the entire system is down. There's a small issue in the system, a small part of functionality that is not working, but yeah. And the next one is change failure rate. So 0 to 15% of the production releases this particular company has done is failing in production, has some sort of an issue, right? I mean, it's happening, right? I mean, you guys are developers, you guys deploy from dev to prod. Always there's an issue, right, in production? I mean, yeah, it's never something called stable production. So there's always an issue in production. So that's how it is. And then deployment frequency, they are doing it daily. Daily they are deploying new releases to production. The more you do deployments, the more chances it's gonna break, because you're releasing more features, right? And then mean lead time to change is 1 week. Basically what that means is a commit that the developer has committed and merged to the main branch or whatever will take 1 week to propagate to production in average, right? It's pretty bad because it takes 1 week when you fix something, unless you hot fix it. Normally for a feature to get released, it takes 1 week. In WSO2, currently in Choreo, I think ours is about a day. So we ship features. Normally a commit goes to production in a day in our company. So that's it. Any other questions? Right. So we'll quickly, I'll go through what deployment methods there are for production. Recommend it to anyone. I don't think anyone will mention this here. Yeah. I think you remember, right? So yeah. The next one is Canary. Canary is what basically you have version 1 running. You introduce version 2 and then send traffic, about 33% of the traffic to the new version, and then 66% of the traffic to the older version, and you observe. You don't do anything, you observe, and once you're satisfied that things are working properly, you change everything to V2, right? That's what Canary is. And normally how we do in production Canary is, we have this system, and then now what we are going to do is we are going to run the API tests. We are going to run the API test or the integration test that we have to V2, and then we check whether everything is working. And once it is done, then we are happy that all the tests are passing, then we change the entire layout to V2. That's how we do it in real life. So the rolling update, which is the Kubernetes native way, and a lot of Kubernetes engineers proudly say we have rolling update in production. So basically, yeah, as the image suggests, V1 is first, the first box is converted to V2, and then 33% of the traffic is sent there. Once V2 is live and green, the second box starts updating, and likewise all 3 boxes become V2. Now there's a problem with rolling update. Can anyone tell me what the problem is? කෙනෙකුට දෙන්න පුළුවන් මේ පෑන. So මේව හිතුවොත් rolling update වල let's say we have this ERP system, මොකක්ද ෆික්ටරි කිව්වේ මොකක්ද මොකක්ද අර වගේ මේ සිස්ටම් එක ඇඳුම් කඩයක් නේ. ඔව් clothing. Yeah, clothing system. හරිද? ඕකේදී checkout එකේ ප්‍රශ්නයක් තියෙනවා, right? But the application builds successfully. Application is running successfully. Checkout is a function you click on the application, right? So a scenario එකේදී මේ V1 එක V2 වෙනවා, and then it is successful. Application is running, your website is running, everything is working. We don't know whether checkout is not working, right? So එතකොට දෙවෙනි එකත් ඉතින් it's going to start rolling, and third one also will get rolling, and all of a sudden we have V2 running, and now checkout is not working, which we have to roll back. But in the Canary case, that's not the case, because අපි V2 දාලා V2 එක against API testing run කරනවා, 30% of traffic transfer කරලා. එතකොට checkout එක issue එකක් තියෙනවා නම් we can stop there and say okay, V2 we are going to roll back, and we are going to leave V1 as it is. That's the problem between Canary versus rolling update. Any questions?
But does that cover under CI, where we run the API testing?
Runtime issues තියෙන්න පුළුවන්. I mean, එහෙනම් ඉතින් එහෙනම් production වල කිසිම issue එකක් නැහැ. That checkout is an example. For example, CI වල උනා in the checkout story, you don't test against the production of the payment gateway, right? In the build pipeline, that is there only on production. You'll be testing against the sandbox environment. So there are many ways production can break, and which we cannot identify in lower environments. That's something that we have to understand. You can get global truth there. That's how it is. Then finally blue-green, the same concept as Canary, but in this case what we do is we spin up V1 and then we spin up V2 and then we transfer traffic to V2 while V1 is still running. And if there's a problem with V2, we straight away push back to V1. Any questions? Right. Top what I just like so configuration management. So this is also in internal developer platforms like on platform engineering and all of it. Configuration management plays a key role. One of the things like is how you spin up your infrastructure. Usually, then we spoke about I think Carling spoke about Terraform. There's Pulumi. Crossplane is coming up. Crossplane is more towards shadow IT, which I will talk in a second. So all of that is good for you to like, even if your cloud goes down or like if you accidentally delete something in your cloud or something like that, very easy to spin up again because you have the code, infrastructure as code in your GitHub. That's called GitOps, right? And the other thing is environment-based deployment code. Like for example, your application, you would be deploying it for dev, production, staging, etc. And you would have different configurations for each environment in most cases. So there are tools to this like customize, Helm can be used. So to manage these configurations. These are in infrastructure environment based stuff. And the next one is runtime configurations. When your application is running, you have to inject some things at runtime. You can't, for development, the database is somewhere else, and for production, your database credentials is different, right? So that is runtime configurations, and same can be sensitive configurations as well. So you have to learn where to save them, right? And also there are build time configurations if you're running some tests or whatnot. There are certain things that you have to pass as build time arguments, right? To do this, the tools are available, which in that CNCF landscape is customized help. HashiCorp Vault, these are the open source ones. Sealed Secrets, another open source one that allows you to manage secrets in Kubernetes in a secure way. Other than that, cloud natively, vendor specific, you have AWS Secret Manager, Azure KV, Google Secret Manager, etc., which would have that auditing and all of that, and securely inject these things into your containers applications, regardless of which service you use. And these are important, and these are the things I think Janaka will also speak when he's doing his security session. These are the things that a lot of people miss when they deploy in enterprises and stuff like that. There are so many plot holes when it comes to security and all of these things. So that's what it is. I think even certain enterprises even commit passwords to their local Git repositories. So that's how bad it is. So yeah. Any questions?
If you're like using Kubernetes, do we need to use like the HashiCorp Vault or something, or is it needed?
It will be, because Kubernetes has something called secrets, but at the end of the day, they are just base 64 encrypted. Anybody can decrypt that, and you cannot commit your base 64 encrypted secrets to a Git repository. You can never do that. So instead of that, if you want GitOps capability, then sealed secrets is a way to do that. So they have a hash and they encrypt it. The YAML that they give, you can commit it to any place and cannot decrypt unless it's a supercomputer or something. But then HashiCorp Vault is an enterprise level story where not only just inject secrets, stuff like you can give a MySQL password to it, and it would even do the rotation for you. Password rotation, it would talk in MySQL and do rotation and inject it back to the container. So it's very cool and has a lot of enterprise capabilities. So if your enterprise is looking for something like that, I would recommend HashiCorp, especially for on premises. But if you are using Google or Azure database, They have managed KV stores, so you can use those. Any other questions? Right, so last two. Observability and monitoring. Of course, the systems need to be monitored and all of it. So there are two things. One thing is having nice dashboards and looking at it, which looks nice and which would make your CTO happy. But that's not what you really. What you really need is information when something goes wrong or when something is about to go wrong, right? So for that, logs and resource metrics, CPU, all of it, you need to have these somewhere to query or figure out. Just having nice dashboards doesn't cut it, and you need to have alerts as well. So alerts is where would give you like something is about to go wrong, so that you can do something to fix it, or give you a resignation or whatever, right? So that's what observability and monitoring is all about. And Prometheus plays a big role in the cloud native ecosystem for metrics. And even alerting, Prometheus has something called Prometheus Alert Manager, which is pretty good to do your alerting. And also the same guys who did Prometheus and Grafana, they have given something called Loki, which manages logs in the cloud native ecosystem. But if you have doubts with Loki, the common thing currently enterprises use is the Elastic Stack. Basically EFK or ELK. F stands for Fluentd, L stands for, I think, Logstash. So other than that, you can use service mesh tools also. Like if you install Istio, there's Kiali dashboard, which gives you a nice trace of how your traffic is doing and gives you a nice diagram. Cilium with Hubble gives the same thing with eBPF. Linkerd with Wiz gives you a live say of each of the API spec that you have, what is failing, what's the latency, and all of it. Very nicely they provide, so you can just Google and figure out which one. And then there are paid solutions like Datadog, New Relic, which has a ton of features which could improve your productivity tenfold in the company with application performance metrics and all of it. So these are cloud vendor specific tools. And I think Fikri spoke about Azure has something called App Insights. Yeah. So these are the tools for those. And then another key aspect of an internal development. Now platform engineering, it stops there. Now for that set of processes to be an internal developer platform, a key thing is to enable developer self-service, which means now you don't have to go and talk to a DevOps engineer or a platform engineer to introduce a service to the system, right? You can just go do it yourself, build your application, set up the CI/CD with a couple of clicks, and then you can own the service yourself because you are the developer. Because you know what the configurations are, you know what the CPU memory requirement for your application is, you know where to mount the files. The developer knows this. So this is where developer self-service comes in. So developer can own the service from dev to production all the way and mount the configurations and everything and be responsible for what you develop. And also it enables you to have your own isolated developer environment where you can have your database or the Redis cache and all of it and test out and do things, right? That's what developer self-service is, and this is how internal developer platforms differ from the processes defined by platform engineering teams. And because it's a platform which enables developers, and basically platform engineers become redundant, sort of, not really redundant, but they become the observers and can just watch things going. Finally, security, governance, and resilience. So I think these platforms, now they are automating processes. You need to give best practices and all of it. One thing is firewalls and network policies. You are creating, developers get to create their own services and manage it. Somebody has to govern it, right? Nobody trusts developers these days. So those things will be baked into the system. And the identity and access management officer, who did what, that's auditing, right? And you have auditing. So in that case, you would know at which time somebody promoted a service, at what time you introduced a new service, who did what. All of that is there. And then API management. Put an API gateway in front, how you manage the API, do rate limiting, authentication and authorization of those consuming APIs, metrics for it. Then you can enforce limits and quotas for your developers. You can say that particular project A can only utilize 16 CPUs and 12 GB of RAM. That's it. Cannot use more than that in my infrastructure. So you can enforce limits and quotas like that, so that you don't get a surprising bill. Then of course service measures with MTLS and everything that it provides would give you security, governance and resilience. That's pretty much it. Any questions? ප්‍රශ්න නැද්ද? දැන් ගොඩක් කිව්වා. මම ස්ලයිඩ්ස් ටික දෙවන්නම් මේ නිකන් ෂේප් එකෙන් බලන්න මේක. And the final thing is build versus buy. So none of you are CIOs or CTOs. This applies only for that level of people, because you can't whatever the company you work in, you can't go and tell them there's this thing, let's buy that, right? You can't do that. You are developers. What you can do is try out new tech and maybe introduce it to company. Even then they probably wouldn't listen to you. That's how it is. Right? That's how everywhere it is. So normally to build an internal platform like that takes some time, needs expertise. Now for me to come here and talk about all of these things, I have about 6-7 years of experience doing this thing. I don't think any of you can come and talk about something like this with just Googling it overnight. You can't. There's a lot of experience factor comes in, and then designing this, knowing which tool to use, and all of it takes a lot of effort. So, and many companies like Google, AWS, Tesla, Netflix, they've built these internal developer platforms for their teams. They've already done that. They've invested huge amounts of money to do that, and that's how they quickly release. But for smaller companies, even medium companies who lack platform engineering capability, don't have money and time to do that. They need it today. So if they want it today, you can actually buy. There are other things like, one thing is Backstage, which is available in the CNCF landscape. So Backstage is pretty good, and using Backstage you can easily build an internal developer platform. It's just the base. You have to add certain things and have the processes around, which would work. And Humanitech, which is the third one here, is built on top of Backstage and has a lot of things. And I put WSO2 Choreo as a second one because I work in that. It's my platform. So, and then there are other things like Harness, Platform 9, Garden, Randoli. I would recommend WSO2 Choreo because I work there. But yeah, but to be neutral, I put everything. So that's pretty much it. Thank you. And I forgot to put a Q&A slide, but that's pretty much it. Thank you so much. Any questions?
These observability tools, do they usually run in the containers itself or like sidecars?
Depends. So observability system is running definitely. Container is a way of running a software. Right? You can even run it on a VM. That's fine. But normally Prometheus or something like that, we run it as a bunch of containers within Kubernetes or someplace else, and then you would monitor. Now there are various levels of metrics that you can take. At the VM level, you can get the CPU memory usage, and from that level, of course, you can get the container CPU memory also. And then you can run as sidecar containers, and you can get more stuff like network proxies, and even going to a level of flame graphs and see what processes that are running. There are so many things that you can do. And then also the sidecar container metrics is slowly dying away, because of the eBPF technology that Carling spoke about. With eBPF, what happens is instead of running sidecars per container, I'm just talking about Kubernetes jargon here. So Kubernetes has something called nodes, VMs. So you run the proxy per VM, the agent per VM, and it's able to, using eBPF, capture all the processes that are running in the as containers and then inject it back to Prometheus. So that's any other questions? No? Okay. Thank you so much, and you're going to welcome John today.
Yeah, thank you.